A stolen car is modelled as travelling in a straight line from a point A, 5, 3, minus 1, to a point B, 7, minus 5, 8. The police are waiting for the car to pass at a point modelled as the origin O. The police have a stinger that they can deploy to stop the car. The stinger is 6 metres in length. So, you can see in blue I've drawn out the path of the stolen car going from the point A to the point B. And here I've worked out the equation of that line where it's going through the point 5, 3, minus 1, and it's going in the direction of 2, minus 8, 9. I worked that out just by taking these 2 points away from one another. You can see I've also marked on the point O, the origin, which is where the police are waiting to try and stop this car. And they have this stinger, this device that's going to try and stop the car, that's 6 metres in length. So if the car goes within 6 metres of the police, if this is less than 6, then the police will be able to stop the car. If it's not, then they won't. So what I've done in red is I've marked on the general point of the car, which is just me taking that equation and combining it together to say that the x point is 5 plus 2 lambda. The general y point is 3 minus 8 lambda. And the general z point is minus 1 plus 9 lambda. I can then work out the vector O to P by doing point P, take away the origin, and subtracting the origin will just leave me with O to P as being 5 plus 2 lambda, 3 minus 8 lambda, and minus 1 plus 9 lambda. And the key thing is when the car is closest to the police, OP will be perpendicular to the direction that the car is travelling in, which we know is 2 minus 8, 9. Therefore, the dot product of these two vectors will be equal to 0. Multiplying these vectors out, and then collecting up the like terms together. So the 4 lambda plus 64 lambda plus 81 lambda. And then the 10 minus 24 minus 9, I've moved that to the other side, tells me that the car will be closest to the police when lambda is 23 over 149. Which I have then substituted in here, here, and here to work out what OP is when the car is closest to the police. I've then worked out the magnitude of that vector to find out how far the car is away from the police. So I've just done this value squared plus this value squared plus this value squared, all square rooted, and that gave me 5.6 metres. So the closest the car goes to the police is 5.6 metres, which is less than the length of the stinger device. So therefore, yes, the police can stop the car. Part B of this question, state one limitation of the model. And the obvious one here is that the stolen car is unlikely to be travelling in a straight line, or that the police are unlikely to stay at the origin. They're likely to move towards the stolen car. Or we could say any other sensible reason for why this is not a sensible model.